Geobyte.
Dear students, I hope all of you clearly understood all the theory concepts what we have discussed for center of mass, momentum and collision. Okay. Now let us take the previous year questions for this particular topic. Look at the very first question. It is asking like this. Three bodies A, B and C have equal kinetic energies and their masses are 400 grams, 1.2 kg and 1.6 kg respectively. The ratio of their linear momentum is, as you know, the kinetic energy K equal to P square by 2m, where P is the linear momentum. But this is a special case where kinetic energy remains same, means kinetic energy of the body A equal to kinetic energy of the body B equal to kinetic energy of the body C. Okay. And look at the masses. Mass of the body A is 400 grams. Mass of the body B is 1.2 kilograms equal to 1200 grams. And mass of the body C 1.6 kilograms equal to 1600 grams. Okay. Now from this particular relation, the square of the linear momentum equal to 2 times the mass and kinetic energy. From this, the linear momentum equal to root over 2mk, where m is the mass of the body, k is the kinetic energy. Since kinetic energy for all the three bodies remain same, from this I can write that the linear momentum is proportional to root over mass. Therefore, the linear momentum of the A is to linear momentum of the B is to linear momentum of the C equal to root over MA is to root over MB is to root over MC, because the linear momentum is proportional to under root mass. Root over MA equal to what? 400 is to root over 1200 is to root over 1600. It is equal to, simplify this, 1 is to root 3 is to 2. 1 is to root 3 is to 2. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Then look at the another important problem. It is asking like this. A player caught a cricket ball of mass 150 grams moving at a speed of 20 meter per second. Here mass of the cricket ball is given 150 grams equal to 0.15 kilograms. That ball is moving with initial velocity v1 equal to 20 meter per second. That ball is caught by the cricket player. After the ball is caught by the cricket player, final velocity of the ball is 0. If the catching process is completed in zero point 0.1 second, the time taken for catching the ball, that is delta t equal to zero point 0.1 second. The magnitude of the force exerted by the ball on the hand of the player is simply what is the force which is transmitting from ball to hands of the player while the ball is, right, catching. As you know, according to Newton's second law, the force which is transmitting from ball to hands of the player equal to rate of change of linear momentum delta p by delta t. Delta p means mass into v1 minus v2 divided by the time taken for the process. Mass into, here final velocity V2 equal to 0. Therefore, it is mv1 divided by delta t. Mass equal to 0.15 kg. Velocity is 20 divided by zero point 0.1 second. You simplify this. 0.15 into 20, 3 divided by zero point 0.1 equal to 30 newtons. That is the magnitude of the force transmitting from ball to hands of the player while he is catching the ball. Okay, understood clearly? Look at the options. Option D is absolutely correct. Okay. Similarly, look at the another important problem. It is asking like this. A uniform thin metal plate of mass 10 kg with dimensions shown in figure. The ratio of x and y coordinates of center of mass of the plate is n by 9. The value of n is, as you know, the equal to mass of the plate equal to density multiplied by volume. Mass equal to density multiplied by volume means area multiplied by thickness. Since thickness is remaining same, density rho remains same. Therefore, I can say that mass is proportional to area. Mass is proportional to. That means mass of the plate is proportional to area. Now look at the cavity in the body. This is the cavity in the body. Let me complete it. First, I am marking the cavity in the body. This is the cavity in the body. That means that is the place where some material is removed. For that, what you do is you consider, listen carefully. You consider this is the block 1 and that cavity is block 2. So block 2 is removed from the block 1. Therefore, the center of mass about x-axis xcm equal to, I can write in terms of area a1 x1 minus a2 x2 by a1 minus a2. Similarly, ycm center of mass about y-axis ycm equal to a1 y1 minus a2 y2 divided by a1 minus a2. This xcm, it is given as xcm is given as x and ycm is given as y. So anyhow, I can write x equal to a1 x1 minus a2 x2 divided by a1 minus a2. Similarly, y equal to a1 y1 minus a2 y2 divided by a1 minus a2. Okay. For that, let us take the another slide. The block is given like this. First, I am taking the whole unit. This is the whole unit. The dimensions of that unit is, let me draw it clearly. Look at the dimensions for that unit. Right. On x-axis it is 3. On y-axis it is 2. Right. 2. So here it is. This 3 with respect to units. This is 2 with respect to units. Okay. Then look at the cavity part. I am marking the cavity part. Take minute. I am marking the cavity part. This is the cavity part. Look at the dimensions of the cavity part. Dimensions of the cavity part is, it is 1 and it is also 1. 1 by 1 is the cavity dimension. 1 and this is also 1 with respect to units. Right. Both are looking like a rectangle. Rectangle. Now, first let us mark it. This is the block 1. This is the block 2. A1 equal to breadth multiplied depth 3 into 2. Similarly, A2 equal to 1 into 1. Next, you join the diagonals for the block 1. Wherever these two diagonals are meeting, that is the center of mass. This is the x1, I can say, and this is the y1. Y1. Look at the x1. X1 equal to 3 by 2 equal to 1.5. Next, y1 equal to 2 by 2 is equal to 1. Next, now I am marking the cavity in the block 1. So this is the cavity. This cavity is at a distance of 1 meter from x-axis, from the left end, and from bottom also it is at a distance of 1 meter. 1, it need not be meter, it is just with 1 with respect to units. Now I am marking the centroid for the center of gravity for the block 2. Join the diagonals. Wherever the diagonals are meeting, that is the center of gravity for the block 2. For the block 1, it is the CG1. For block 2, it is CG2. CG2. Now, this is the x2. Listen carefully. This is the x2. And this is the y2. Y2. Now, look at the x2. X2 equal to what? This is 1. 1 plus, right? You know, this distance is 1. So 1 plus 1 by 2 is equal to 1.5. Similarly, y2 also equal to 1 plus 1 by 2 equal to 1.5. Okay, then centroid centroid distance on x-axis, a1 x1 minus a2 x2 by a1 minus a2. A1 3 into 2 equal to 6. 6 into x1 1.5 minus a2. A2 is equal to 1. 1 into x2 1.5 divided by a1 6 minus 1. It is 9 minus 1.5 divided by 5 equal to 7.5 divided by 5. That is the x value. Similarly, centroid distance on y-axis, a1 y1 minus a2 y2 divided by a1 minus a2. A1 is 6 y1 1. 6 into 1 minus a2. A2 is 1 into y2 1.5. 1 into 1.5 divided by 6 minus 1. The 6 minus 1.5 by 5 equal to 4.5 by 5. You got x value equal to what? X equal to 7.5 by 5. 7.5 by 5. Y value 4.5 by 5. Therefore, x by y equal to 7.5 divided by 5 divided by y value 4.5 divided by 5. This 5 cancel. 5 cancelling. Finally it is equal to 7.5 divided by 4.5. That is the ratio between the centroid on x-axis and centroid on y-axis. 7.5 by 4.5. So we got here x by y equal to 7.5 by 4.5. But look at the ratio given is n by 9. So therefore you multiply it on both sides by 2. 15 by 9. It is given as n by 9. From this I can conclude that n equal to 15. So n value is 15. Understood clearly? Yes. Similarly, it is very important. 5-star problem. 5-star problem means most expected problem. Understood clearly? Yes.
Geobyte.